Hello, everyone. I'm here with the lecture for today, a little bit later than usual, but unfortunately, I was caught up with a lot of stuff today. So, anyway, I hope that this lecture comes at a good time for you, and I hope you have some enough time to watch it in the next few days or week. This lecture is about mining networks. This is now we're starting to step away from the idea of having these, data set as we think about it in terms of just like vectors of multidimensional space. And we're starting to think about data as it is structured in different ways, right? And that's what a network is. Basically, a network is a data set, just like the normal Euclidean data set. But instead of having Euclidean coordinates, we have connections between points. This is the structure of the data set. It's just nodes and their connections, right? And this first part talks about community detection. So let's go for it. Networks and communities. So this is a network, right? As we see over here. Actually, this is a drawing of a network, right? So it's very important that from now on, when we talk about networks, you remember that this thing here is simply one way to visualize a network. This is not the network itself. First, because a network can be visualized in infinite ways. And second, because the network is by itself simply a data set, right? It's a data set that can be visualized like this, can be visualized in some other way. So this is not the network, but it's one view of a network. And so that we have the data set, and it can be structured in different ways, and it can be visualized like this. But basically, what we're talking about here is a set of nodes, right? Each of these squares here is one node, which would be the equivalent of what you're used to as a data point, right? And these edges, these are connections between the nodes, right? So these connections between the nodes, they kind of like give the structure of, there's basically, in a basic network, there's basically nothing else, just the connections, right? The connections are the things that give the structure to the data set. And when we look at a network like this, usually the first pattern that comes to mind, in the same way that it was with clusters, right? The first pattern that we talked about in the course was clusters, because this is usually the first thing that comes to mind when you look at a data set and think, well, I want to find patterns. And usually patterns are clusters. In the community, in the networks, it's the same idea, but with the community. So a community can be seen more or less as a cluster in a network. It's not exactly the same, but for our definition right now, for our course right now, it doesn't really matter what are the exact specific differences. So let's just think of a cluster or a community as a cluster in a network. So we want to find these modules or these communities where these people who are inside a community, they're very tight. They're very close to each other. There's a lot of connections between these people. And at the same time, they're not so well connected to the outside, right? Of course, they don't have to be necessarily completely isolated, because that would be an extreme. Like the extreme of a cluster or a community would be that it's completely isolated from the rest of the graph. That's not really what happens in practice. In practice, you have these patterns, right? These patterns of these groups that are very tightly connected between each other, and they have some connections to the outside, which are not as strong as the ones that are inside. So what we really want to look at is this balance between a very tight community and that is weakly connected to the rest of the communities. Okay, but it still forms a full graph where everyone's connected to everyone in a certain way. It doesn't have to be isolated. That's the idea. And this, in this case here, for example, this is an example of a one output of a community detection algorithm that has colored these nodes according to the detected community that they're part of. And you can see that, for example, from a distance, let's say in an overview, you could say that there are three big groups. Let's say this one, and this one. Let's say, and but if you drill down a little bit and you want more details, you can see that each of these three big groups are also like partitioned uh, into smaller groups inside of them that are less clear but are still there. This is one example of the kind of analysis that you would do in order to find communities in a network. You might start from finding like big groups, and then inside each big group you might find smaller groups. Like for example, the big group could be the university, and then the whole graph could be the university, and you could have different big groups that would be like the faculties, and then inside the faculties you could have smaller groups of department, and then even smaller groups for research groups and so on. So yeah, so this is the goal of what we are going to talk about today. It's just algorithms for taking this graph and then finding the communities in this graph, right? This example here is actually what I was talking about, this idea of having researchers. So in this case, this is just an example of a co-authorship network, as we say, which is basically just people who have published papers together. I'm gonna come back to this later and talk a little bit more about this. But this is basically just one example of community structure in a graph. And the interesting thing about this is that this idea of communities it's the same thing with clusters. It's not really necessarily a theoretical. I mean, there are many theoretical underpinnings, but the truth is that in practice, if you take a real world, let's say, graph, you usually see a lot of communities in it. While if you generate a graph randomly, you may or may not see that depending on what generator you're using. But what I mean is that this is usually like the kind of pattern that happens in real world applications, right? It's very easily observable and very well studied, the fact that networks do form communities in practice. And this is what we want to detect, right? We want to be able to take this graph and then find these communities and then try to understand why they are formed. This is just a very simple example also of these communities. For example, you could consider that there's a social network, right? Like Facebook or Instagram or whatever. And you're connected to people, right? You're connected to your friends, you're connected to your family, you're connected to many different types of people. And these connections that you have, they also form little communities within them. Like for example, let's say you take all your family members, right? I mean, it's quite probable that they are also connected within themselves, right? So for example, if you have your mother, your sister, your uncle, they're probably also friends with each other, right? And so they will form little communities if we just consider all of your friends. Let's say we focus on you. That's why it says your ego. That's you, right? So basically you're the center of this specific network, and then we just extracted, let's say, all of the friends of your friends from Facebook and the possible connections between them. So and then you have high school friends over here. And the interesting thing is that you have family members, they are your friends in Facebook, and you have high school friends, which are also your friends in Facebook. But probably, with some exceptions, your family and your high school friends are different communities. They don't interact so much. I mean, of course, probably some of your high school friends are friends with your mother or your sister or your brother, but in general, they will be two different communities without too much overlap. And then if you go and say, for example, college friends or university friends, they are also going to be probably a different community. And probably, like, if you moved away, if you're living in a different country or in a different state, for example, then these university friends may not even be connected to your family at all. And maybe there's like a couple of high school friends who actually decided to go to the same university that you did. And so you kept them as university friends. But again, this overlap is probably very small, especially if you just moved away and you went somewhere else. And so on and so forth, right? I mean, you take this community, and then you can also think about this hierarchy of communities. Like you have university friends, you have department friends, you have people who are working under the same advisor. So you can form this kind of hierarchical structure of communities, which is actually something that we are going to explore a lot in the next few slides. And this idea of hierarchically detecting the communities, the same way that we detected hierarchical clusters before. But the idea, this is the basic idea. There's not much else to it. It's just, okay, take this graph. Let's look for patterns in them in such a way that we find groups of tight communities that are slightly separated from other groups of tight people. And we hope that when we do it, the actual results will give us some kind of interesting pattern and a way to make a decision about the network and gather some knowledge about it.